Hey, welcome back to Robinson Foundry. In today's video, I'll be using 3D printing and metal casting to make a really interesting maze bolt puzzle. I made a similar one last year and it turned out great, but it's just a little bit too easy to solve. This one will be much more difficult to solve, but also making it will be much more difficult, so let's get started. I designed the maze bolt in Fusion 360 and then 3D printed it in different pieces, and I figured that since I'm making one, I might as well just make two. The maze will be cast using a method called lost PLA and ceramic shell. The PLA is the plastic the maze is made out of, and this yellow stuff is a ceramic in liquid form called slurry. I dipped the models into the slurry a total of 9 times. After each coat, except for the first, I sprinkled the slurry with this fused silica sand. This helps strengthen and build up thicker layers. At around coat 7, I wrapped the shells with some thin steel wire, which will act as rebar and hopefully prevent the shells from cracking later on. The shells are done, so next I can start melting out the 3D prints. I placed them inside my kiln and slowly brought up the temperature to the melting point of the PLA plastic. This way, the plastic can melt out of the shells and I can remove most of it rather than just burning it away. Once I removed the plastic that had melted out, I put the shells back into the kiln and fired them at 1500 degrees Fahrenheit. This turns them into a ceramic that I'll be able to pour 2000 degree bronze into. As the shells were heating up, I started melting some metal. I needed 12 pounds of bronze to fill both molds, so I made my own using 92% copper and 8% tin. For a source of copper, I mostly use wire, but for tin, I use these pewter cups. They consist of about 95% tin. I waited for the copper to completely melt, and then I added in the pewter cups and gave it a stir. Once the bronze was at the right temperature, I quickly removed each shell and blew out any remaining ash with a little compressed air before placing them inside some old crucibles. Then I quickly poured in the bronze. The funnel-shaped pieces that I attached to the mazes are called screws. They act as reservoirs and supply the casting with liquid metal as the metal solidifies and shrinks. And they have to be really big so that they're the last parts to solidify. I let the shells cool down for a while and then I sped up the process with some water. Removing the shell can be really difficult, especially if there's a lot of small details like with these. After breaking off what I could, I used my sandblaster to blast off the rest. Now I can remove the screws and use them to cast the bolt heads later on. I couldn't be happy with how these turned out. The detail is really crisp, and the shell even picked up all the 3D printing layer lines. After machining the surface a bit, I drilled and tapped a hole for a half-20 bolt. I really wasn't sure how I was going to polish the maze, but a wire brush did a pretty good job. However, I felt like it needed something else, so I stuck it in the lathe and, using some sandpaper, I polished the high spots. It's kind of hard to see it in the video, but this really brought the maze to life. With that done, now I can cast the heads. The patterns are also 3D printed and have large sprues to prevent shrinkage. I'm using a special oil-bonded sand called Petrobond. It does a great job at capturing detail and patterns, and if the mold is made properly, it can produce some really nice results. I cast these heads with large sprues that served two purposes. They prevented the castings from shrinking, and they will also be machined into threaded screws that will screw into the bolts. To cut the threads on these, I used a process called single point thread cutting. It's fairly simple, but it was the first time I've done this, so it was a bit of a learning experience for me. But it went well and the threads really turned out nice. It's really incredible to me that you can end up with very nice looking machined parts like this from raw castings. Next I used a Dremel to polish the inside of the heads until they were nice and shiny. Next I started working on making the nuts. I started with a piece of aluminum that I machined to the correct thickness. I also drilled a 1/2-inch hole through the center. With a pin inserted into the hole, now I can clamp the piece into the vise, resting on the pin, and easily rotate it into the 6 positions of the hexagonal shape of the nut. With the hexagonal shape cut, I bored out the hole to fit nicely over the maze. Next I drilled and tapped a hole on each face for a set screw. I'm sure I could have power tapped these holes, but I'm not very experienced with that, and I really didn't want to break a tap at this point. Only one set screw will act as a key that will engage with the maze threads, and the others will be dummies. This adds a layer of difficulty to the puzzle, as you have to keep track of where the key is while solving the maze. If you lose track, then solving it becomes significantly more difficult. That's why they're set screws. If you give up, you can simply back out the screw and start over. To finish these up, I sanded the machining marks off of the larger faces. I went all the way up to 2000 grit, which gave them a very nice shiny look. The brass set screws that I got needed to be cut to length, so I cut them with the lathe. I also cut a little point onto the end of 2 of them, which will be the keys that engage with the maze threads. I'm really happy with how these turned out. This was a long project with a ton of steps, some of which were new to me and took me out of my comfort zone with machining, and that's a good thing. That is, after all, how you learn how to do things. I could have made this in many different ways, but I chose to do it the way I did because I thought it would yield the nicest results, and I think I was right. They look really nice, and I couldn't be happier with them. And if you're wondering why I made 2, well, sometimes I like to make 2 of something, especially if I'm making a video about it. That way, if something goes wrong, then I'll have a backup, and if everything goes right, then I'll end up with 2. As for solving them, well, I haven't yet. It's a pretty difficult puzzle, but I'll keep working on it. If you would like to follow along with the process of my projects, then consider joining my Patreon. I post multiple Patreon-only posts a week there, and you'll also gain access to any of my 3D printing files, including this maze bolt, which I redesigned for easy 3D printing. I'll also have the exact files used in this video available. Well, thanks for watching, and if you enjoyed the video, please let me know what you think in the comments. Give the video a thumbs up and subscribe for future videos.